Going live. Here we go. Hi, everyone. All right. Looks like we're live now. Welcome to my stream. I'm Joey B, and you're watching BPS. No, Joe Barnard. You're watching the Joe Barnard channel, which means the content is less than half as good as on BPS. It's uncurated, and I'm drinking seltzer. I wanted to point out I'm drinking seltzer without alcohol in it. And it's just regular. It's Kroger brand seltzer. It's very good. And so we're gonna machine some polycarbonate today. I don't know if it's machining or milling. I feel like you can't call it machining if it's not metal. But that's what we're doing today, and I'll show you what we're doing it for. Okay. So in the top left of your screen, you can see what is the avionics stack for the level 3 rocket that I'm building. And in just a few days, I should probably raise this camera up. In just a few days, I will put out a video on the BPS channel that has a little bit more detail about what this rocket is doing. But I want to get more of the avionics stack done before we actually do that. So what we need to do is machine some sleds for it. A sled is a thing that is going to hold the flight computer on. Boy, I do not know how to use the touch controls on Fusion. Oh god, this is awful. Okay, yeah, so Ava goes on this sled. It's polycarbonate, and the reason we're doing it this way is, according to Charlie Garcia, in his words, the goal of the flight is to get the flash chip back, and it's a lot easier to get the flash chip back if we have materials that play nice when they hit the ground very, very hard. Of course, you don't want to hit the ground very, very hard. You want to hit it softly, but you design things so that even in the worst case scenario, you have a decent chance of getting it back. PLA is very brittle. ABS is a little bit better. Some parts on the rocket are going to be ABS. And polycarbonate is the most friendly and pretty stiff, which is great if you're carrying sensors on board. So Ava is on one sled. A telemetrum by Altus Metrum is on the other sled, as well as a small run cam. I have a test print here. This is a run cam split 4. Again, I'm going to talk a lot more about this on the BPS channel, but we're making 2 sleds today. They look like this. Super exciting, very riveting content today. And we're making them out of polycarbonate. So this is the sheet we're making it out of. It comes with this sort of plastic protection on there. Yeah, that's that. Take a sip of my non-alcoholic seltzer there. Okay, so yeah, this is the machine. It's a carbide. Oh my god, what is it? Nomad 883. Carbide donated it to me like a year and a half ago now, and it's been great. I haven't used it very much. I did some test machining over the summer. It's not a very strong machine. It's great. It's super accurate for really tiny parts, but you can't do a whole lot of metal unless you're willing to sit for a very long time. All right, well, thanks everyone for joining. I don't really know how long this will be. And someone says, how do I skip the CNCing? I got bad news for you, buddy. How do I skip to the CNCing? That's a better question. Well, how about we start? So we need to take this, what is it, like a cheese board? I don't know what you call this. This cheese board off of here. Get this out of the way. I want to take this bottom board off and then put a waste board on there, because I'm gonna sort of mill into the waste board a little bit, and that doesn't work so well if you're milling directly into aluminum. That doesn't play so nice. So we need something that's more friendly for the bit to plunge into. All right. Should probably take some questions here. Also, the 3D printer is going in the background. If you hear that, that's what that is. Okay, I made this a lot worse. Hold on. Jared says he's working on the Nightbot. Excuse me. Okay. Hi, Ricky. Jared. I saw Eric Spittle in here earlier. Seeing a lot of names. Okay. So this is like the total... Oh, look at that. This is like the total baseboard of the machine right here. And you really don't want to drill into this. It would be like okay to drill into this. You'd break a bit, or you'd ruin the baseboard. But this is like integral to the machine, and I'm just now remembering that all of the fun of machining is vacuuming. Hold on. So there's all these aluminum shavings here, and that's from all of the stuff that I did this summer. You can like go back and see them. I'm gonna record this actually. So I'm gonna be recording a lot during the stream too, because I'm like all at once creating content for this channel and for BPS. There we go. Whew. Okay, now the waste board, which is going to go right here. Turn off my notifications here. All right. I haven't eaten food all day. Please tell me to stop working. Oh my God, Cheeseface Joe. Eat some food, man. Eat some food and step away from the Bosch sensor. I saw your thing in the Discord. I can't help you troubleshoot right now, but go get some mac and cheese, my guy. All right, this goes here, and then this is going to be sort of a newer technique. So we're not concerned with precision on today's thing. We're not concerned with precision, so I feel okay doing double-sided tape to hold the polycarbonate on instead of clamping it down. Oh God, am I going to regret that? Nope, too late. I've committed to the bit. We're doing double-sided tape. I've committed to the bit. What are you making, says Casey Schmidt. Welcome, Casey. For those who did not see earlier, we are making sleds, or sort of avionics bay components. All right, this is absolute malarkey. Hold on. We're making sleds for flight computers to ride on inside of the Level 3 rocket that I'm building to try and fly this spring. Okay, Atlas Aerospace. Get out of here, man. All right. Here we go. I'm not interested in the advanced rocketry stuff. I'm kind of done with that. All right. Here we go. So we're just going to tighten this down, and then we're going to double-sided tape the polycarb onto it. Okay. Boom. That's the polycarb. I should probably take this off. It's going to get all... I should have done that way slower. I'm sorry. Oh no. That was a really nice opportunity to get like a slow motion thing. Oh, I'm sorry. That was like a sin. Okay, well I guess we just have to do it for the other side now, which is actually better because you don't want to double side tape this. Alright, you ready? We're going to do some ASMR, folks. I've got a microphone on this UV light, which is ridiculous, but whatever. Here we go. Okay. We're going to get in nice and close. Yeah, here we go. This is going to record in 4K, too. bump up our aperture a little bit, get some more stuff in focus. All right, you ready? Everyone be very quiet. Bro, this printer needs to shut up. All right, screw it. No, okay, no, I'm pausing the printer. I can't do this. It has to be perfect. Please, for like 1 moment, be quiet. Okay.
Very quiet. Welcome to Joey B. ASMR. Thank you all for joining me today. Now, we're gonna take whatever this thing is off of the plastic. Thanks so much for joining. Here we go. I'm not very good at ASMR. Please support me on OnlyFans. No, that's something else. Never mind, don't do that.
All right, that took a weird turn. We're gonna turn the printer back on, and we're gonna forget about this moment. Resume print. Okay. I'll take things I am not feeling so sure about for 500, Alex. All right, so let's tape this bad boy down to the wasteboard. That's great. I'm glad I put 153 people through that. Thanks for joining, everyone. Tilt this down a little bit. Grab some double-sided tape. Okay, so I have this stuff, which is pretty good. Oh, wait a minute. No, this is better. Okay, so the machine came with this double-sided tape. This is, okay, there's VHB by 3M. There's VHB. What's the medium one? It's like VMB, very medium bond. There's very high bond. And then there's like medium level double stick tape. But this is really spongy, right? It's like very compressy. This stuff is double-sided tape that is a lot less compressy. So let's try this. I'm gonna put it on the surface of the material first, and then we'll push it down onto the table, onto the wasteboard. Okay. Oh yeah, this is going to be really good. Scissors. And I'm just going to use a bunch of this. Like, I would say probably more than I need to. Oh, this is maybe a bad idea. Okay. I'll do 3. Someone tell John Krause to get into my stream and stop texting me about Jeff Bezos. Or maybe he's here. Okay. All right. Here we go. Nice and adhered. Slightly concerned about getting this back off. And this camera is starting to get mad at me about overheating. Oh boy. Let's see if that helps. Finger oils. Oh, give me a break. It's not that bad. Okay, so now this goes onto the wasteboard. We need to speed this up. I mean, as par for the course for like most Joey B streams, this is absolutely terrible in terms of how long it's taking. This, I don't have time for the ASMR. Sorry. We're just gonna peel off with my knife. Gonna peel off the tape. Oh my gosh, get off. There we go. One. Oh gosh. This is very sticky. One. Oh my god, stop! Trevor! Okay. Alright. This is backfiring. Here we go. Oh, I didn't post about this on Twitter. I should have done that. Let's do that right now. Close. Here we go. Great. There we go. I'm milling stuff out of polycarbonate. Okay. Hey man, there's a spider on your chair. Do not do this to me right now, sir. Or ma'am. Okay. Ready? 3, 2, 1, 2, 3, buckle my shoe. Oh my gosh. Stop! What is... I'm gonna lose my... Stop texting! Let me mill my stupid piece of plastic in peace. Alright, this is absolutely good enough. Alright, I'm turning off sound. Oh my god! Disturbing the peace. Just trying to drink my non-alcoholic seltzer in peace. And you can tell that it's non-alcoholic because I make that face when I drink it. And it has this logo that says, there's no alcohol in here. Okay, now it's time to manufacture these things. And we're going to start out of the telemetrum sled. So this one is the simpler of the two. Okay, this is the simpler of the two. And I haven't done this in a hot minute. So you will have to bear with me for a second. So first we need to select like what the material... Okay, we need to set what the stock comes from. There we go. Stock side offset. Oh god. All I really care about is the height. And then as long as we're careful about our lead-ins and lead-outs, we can just sort of plunge into the material and call it a day. Let me get my calipers. So, did you know, by the way, that you could do this with calipers? I am a little ashamed to admit I didn't know that you could do this until just recently. Check this out. These are like your calipers, right? You can use them to measure things in all sorts of ways. Here we go, right? You get like, you can measure my finger this way. You can, measure the bore of a hole this way. You can also measure depth like this. Isn't that cool? I didn't know that. I don't know why I didn't like put those dots together. But yeah, so the depth of our stock material is roughly 9 point... Okay, I'm not doing a good job holding this. The non-alcoholic seltzer is getting to me. I'm going to call it 9.4. I think it's technically quarter inch. But we're doing it in millimeters because, sometimes it do be like this. So, fixed size box. All right, height is 10 millimeters. You know what? That's probably fine. Let's just leave it. Okay, depth is not 180. Let's call depth. Oh, this is. Hold on. Where's my ruler? Okay. Perhaps one day I will run a stream and it will not be a nightmare disaster. Okay. Well, let's just say what the stock is. Yeah, 22. It's a fixed size and we can move things around. So the width, I guess we're doing this in a little bit of a different way. Oh, God. Don't we... I'm forgetting axis definitions. Front. Yes. I'm doing this the wrong way. Okay, hold on. Cancel. This needs to be sideways, and we can just, like, futz it around a little bit. Oh, please stop. Oh, no! Okay. Here we go. S, move, copy, components, this, oh, that, front, we'll do this, and then 90. Oh, shoot. 90. Great. The chat is really going crazy, and I'm a little afraid to look at it, so we're just not gonna. Okay, great. Let's talk about stock material again. It's a fixed size box. It's 22 width, or 220 rather, 220 width. The depth is absolutely dummy thick at 150. I guess we could do both parts like this, but I'm a little scaredy cat, so we're not gonna. Okay, round up to the nearest 10 millimeters. Yes, this is all fine. Okay, stock material is great. Now we can move things around in the stock. Can I not? Oh, stock. How do I move the model around in the stock? Go back to where you were setting the stock size. Nathan, help me. How do I move the model in the stock? Change home point from center to edge. There we go. That makes a lot of sense. And if I could only figure these things out. Okay, no work coordinates offsets. Yeah. Okay, this is good for now. Then I can change. No, that has to be in the. Oh, God, this is really. Oh. Wait, can't I? This is, okay. All right. This is dumb and I hate it. So what we're going to do is not. How about it? Instead of the dummy thick 150 millimeters, we're going to do this right here, we know that it is 50 wide, and we're going to say that our stock is 60. Right? There we go. And as long as we don't go outside of the stock, we'll have no overhang. 60 millimeters. We're right in the friggin' center. Look, the parts just need to get done. This is already... I'm already so not into the idea of milling these and would rather just, can we please maybe not? Like, this is... having a very hard time not swearing. Okay, model. Body. How do I move the body within this? Oh! Origin, stock box point. Yes. That's what I want. Oh, okay, yeah, right, okay. That's the origin. Okay, got it. Yes, that's the origin. I'm sorry to everyone doing this. Also, the work coordinate system is totally borked. This is not correct. I hate this. I hate this. This is so dumb. I should just print it. I gotta practice more, Joe, says, well, I'm not reading that right. You gotta practice more, Joe, says Charlie. That's correct. I should just slow down a little bit and let's work through this. I did it over the summer. The z-axis is correct. I think flip y-axis. All right. Nomad 883. Work axis. Wait, this is stupid. I can just go into here and say, all right, what does x plus look like? That's x plus, and then y plus is back. Cool, so that's all I need. Z plus is up, so then I can just do this right here. Select z axis, that's correct. Y axis is this. Oh, that's not correct at all. I mean, what is even happening here? Okay, if you make your name Flat Earth Believer, you get banned. And I'm not. I get to hang out with whoever I want, and I don't care about that. Well, this is going very well. Okay, should we start a new setup? Perhaps we should start a new setup. Let's just get rid of this and try it again. We know this is our front position. This is how it should look. We're going to create a new setup. Look at that. We're already grounded at the right place. This looks great. Honestly, we could just go from here, although we do need to cut it out. So yeah, we'll do... Oh my god, this is already correct. So I just borked something last time, and we're not going to worry about it too much. Here we go. Relative size, let's say stock offset is 5 millimeters from the side, and that makes sense because it's 50 wide and we're allocating 60. We could actually do more, but that doesn't really matter. It's stock offset top, because this thing is, how big is it? Let's just measure here. Oh my gosh, please. Oh my gosh. How do I rotate? Okay, it's 7.5, so we need an offset of 2.5 on the top. We're going to edit. We're going to stay calm. 2.5 on the top. No bottom offset. And the side offset is on all sides. This is going well. We don't care about the post-processing stuff. The axes are correct. And now we can create a new operation. A round of applause for not totally losing my cool, but just coming very close to it. Okay, excellent. We're doing great, sweetie. Let's create a new operation. We're gonna do 2D milling on the face, and we're gonna get this thing down to the level it needs to. The tool is a 1/4 inch bit. Oh boy. 1/4 inch flat end mill. That's what it is. Yeah, I guess we'll just search for it. 1/4 inch ball. Does E stand for end mill? Flat end mill. Here we go. 1/4 inch flat end mill. Yeah, let's do it. It's a 1/4 inch flat end mill. That's all we need. Now, I don't have a good idea of what the speeds and feeds for this should be. So, okay, big green idea. Just do a 2D contour op. Let's do it, Charlie's. Sorry, Charlie, singular. Let's do a 2D contour. And the tool is still a 1/4 inch. Wait, no. Because we can't get a 1/4 inch in these holes. No, we're doing a facing operation first. Because we need to grind down a lot of material. Yes, no, I stand by this. Facing, tool, 1/4 inch. I'm not going to deal with the speeds and feeds yet, but let's do, yeah, so stock selections. We're doing this. Heights, right. Forgot about this. Okay. So the retract height, feed height, and then the top height is stock top plus, let's say, 1 millimeter, which is more than we need, really, but bottom height is the model top, yes, minus nothing. The retract height, we can put it at 7. How's that? That makes it happy. Okay, the step over. Gosh. Why not just buy stock the right thickness? That's a great question, Charlie. That's a great question, and it will become even more clear on this, not this part, but the next one. I just want to congratulate you on a great question. All right. The step over is the horizontal step over between passes. I don't really want one. We're going to put it real low. Both ways, multiple depths, yes. The maximum step down, let's just say 1 millimeter. That feels really shallow, but I'm worried because this machine, although it's quite nice, is also quite weak. Should we see what it generates? The spindle speed is 12,000. I think the spindle speed for this is 10,000. Spindle speed Nomad 883. Yes, it's 10,000. The oh, that's the ramp spindle speed. Oh gosh. 10,000. Surface speed. All right, let's get some recommendations. This is a Nomad 883. Yes, Ricky is right. It would make too much sense to buy stock material of the right thickness. I also, at the last minute, I bought the stock, and then at the last minute realized that some of my components were going to plow into the side of the airframe, which is not critical path. So instead of buying new stock material, I said, screw it, I'll make this work. Okay. Check the super chats. I can do that. Hi, Joe. I'm a mechanical engineer that does tornado research doing UAVs to deploy Arduino-based sensor packs. Any tips on translating that to YouTube? My goodness. First of all, so FCON 1, that's really cool. Using UAVs to deploy Arduino-based sensor packs. That is really cool. Any tips on translating it to YouTube? So I guess the biggest tip is show that you're passionate about the stuff that you do. This is not to say that it will work for everyone, but what worked for me, like the YouTube channel was around for a few years before it really took off. And what worked for me is when I would dive into the data and like what I was interested in about each flight. You can see it at like the videos that started in like the fall of 2018, where I started explaining things instead of just showing what I was doing. And then I think just like being excited about the stuff that you're working on goes a long way, and people can tell. And that's what I like about the people that I watch. And then Luke Prail says, you missed a super chat. Oh, geez. Sorry, folks. Okay. So let's talk about, all right, cut speed per minute. I mean, what do we think? Meters per minute. That's such a weird... okay, Nomad 883. Sometimes they have these things too. 883 speeds and feeds. They sometimes will have a PDF. I remember finding one. Getting started. There's like a sheet somewhere. Oh wait, this might be it. Placing the Nomad bed. Let's just go to the website, Carbide. It's also a lot more forgiving if I get it wrong here, because it's just plastic. Help. Docs. Here we go. What cutters can I use? Lubricate the rails. General. How about that? Huh. Okay. I am going to keep looking for like 2 minutes, and then if I can't find anything, this is not it. Gosh, it's somewhere. Speeds and feeds. There's a document. I swear there's a document somewhere. It's just not super easy to find. Oh! Oh! Bingo! I said that I got him! Okay, polycarbonate. That's probably close enough. Like Delrin. Okay, depth of cut. I hate that these are all in Imperial. This is the reality. Thank you, Philip. Philip says, I hope your cat has recovered from being dead. He has. Strangely enough, he has. Enough people have super chatted, and my cat is back from the dead. Thank you all so much. Okay, great. So these are, yeah, Ricky points out these are for a 1/8 tool. You know what? We're gonna start with this, and then 90. Like, what does 90 even mean? Should we just try it? I'm kind of feeling like we should just try some stuff. So depth of cut. Can we change this to Imperial? let's look. You know what, man? This feels fine. What's the worst that's going to happen? What's the worst that could happen? You know? There's a 1/4 version out there. Okay. Here we go. Okay, so then what I'm going to look up is Nomad feeds 125. What's a quarter? 1.25. Oh, just 2.5. Nomad 83. 25.jpg. Come on. Please give it to me. Oh! Bingo, zingo, bango, zango. Here we go. 250. Okay, got him. Depth of cut. Let's use ABS. I don't trust polycarbonate. It doesn't even matter. They're like so close. Oh, this is also... Oh, that's the Shapeco. Ah, Shapeco. This is killing me. Screw it, man. We should just try it. What's the worst that could happen? I never use this machine. The worst that happens is nothing. Post-process. Let's go, buddy. 101, carbide 3D, millimeters. If it goes too fast, we'll slow it down. How about it? Use the Shapeco chart? Really? It goes too fast, though. This is killing me. All right, fine. Depth of cut, 0.07 inches. What is 0.07 inches in millimeters? 0.07 in mm, 1.77. Okay, that's the depth of cut. I'm about that. I'm a little shallow. And then this, it's also a faster RPM. And the feed, is this inches per minute? This is inches per minute, isn't it? So 65 inches per minute. What is 65 inches? 5 inches in millimeters. 1.6 meters per minute. This is so cursed. 1.6 meters per minute. Oh my god, it's like pretty much there. It's a little fast. Let's bring it down to like 1,500 per minute. Boom. Oh my god. Right, because the stock is there now. So let's go a little further on the facing then. Pass extension. Step over. Let's do like a 4 millimeter step over, and then 4 millimeters here. And that way we've got plenty of room. This is stupid. We should just do it. The worst that happens is nothing. We crash the machine. Oh no. Let's do it. Here we go. Post-process. Millimeters. Boom. Okay, and then we're going to go to desktop, new folder, Mech 3. Facing 1. Okay, bingo. Now, in carbide motion, we're going to run. Okay, done. Run. Oh. No, not what I want. Info, load. Load new file. This is going to take a while. All right, run it. Okay, measure the tool. Oh, forgot about that. I put a little light there because I wanted to see better. All right, insert the new tool. Oh, look, there I go. I inserted it. Hello, Bo Jarnard. Thank you, Wes. I missed your super chat. I'm sorry, Wes. Thank you for the $1. Says I'm not look. Oh my god, the cover. All right. I don't know. This speed feels about right. So we're gonna do this because I set the oh! I didn't set the home position. Oh my god, I'm an idiot. What is buzzing? I'm a big dumb idiot. Stop. This is what happens. I'm not a machinist. Oh. You can lose steps as a treat. Drinking and machining, what could go wrong? All right, here we go. We gotta set that home point, boy. Oh, bruh. That's not great. Oh, this like dug in there. Uh-oh. Oh, we like went into it. Understood. Have a nice day. Yeah, that sucks. Bruh, oh, can we not? Oh god, limit switch hit. This is insane. Oh. The 3D print would be done by now. Okay. Sure, I'll measure the tool length. Okay, here we go. I went right into that. Woo! Oh boy. Alright. That's fine. We're gonna see if we can keep it like this. Oops. Went right into it. Alright, let's... Okay, well that's going to be our home point, I guess. Be a little offset. And then down. That's the top. And that's that. Here we go. 1, 2, 3, set 0. 0 all. Done. And now we need to reset the work coordinate system because I goofed it real good. Oh my god, it's insane. How do I do that? Work coordinate system, box point. There. That's the home. Okay, great. And now I need to redo this. Right, it's telling me it's mad. There we go, redo. Post-process. Yes. In mech 3, facing 1. We're going to do facing 2 because just keep all the files here. And then in info load. Oh my god. I hate this. Load new file. Facing 2. Run. Run it, boy. Oh. Yeah, I could have whittled it out of wood by now. That's a great way to put it. Alright, let's roll on this, just in case. Is it going to ask me to change the tool? I swear to God. Oh my god! It's in there! The tool is in there! Alright, here we go. Please. Ready to pause. Oh my god. Just end it all. Just end it all right now. I am so close to committing to the printer. Great, I love it. I love measuring my tool length. That's great. I can't say that. Hold on. Look, buddy, you're supposed to start a millimeter up from the top. Let's just give it a little bit more space this time. I mean, what the hell happened? I set the home position correctly. Oh! No, that was from the stock top. I made a mistake in saying that, didn't I? That RPM sounded very low. Yeah, I bet it did, because it can't go faster than 10,000. It's at the max speed. All right. Stock top 8. Right? Feed height, 5 millimeters. How are we not... Stock offset. No. Top height, stock top. Stock top is applied to the relative top height. What if it's 3 millimeters? I don't know. And then what's our depth of cut? The maximum step down is 1 millimeter. I don't know. This still feels fine. The plunge feed rate could be a little slower. Like, I don't know. 300. Great. Now we have a lot. Let's try this. Post-process. Boom. Do it. Why does it keep going to mech 2? Mech 3. Facing. Facing 3. Carbide. Info load. Oh my god. Fine. Measure my tool length. Thank you. Lose my mind. Alright. Info load. Well, okay, go to home. How do I... Rapid position. Current offset. Oh, I should turn the recording off. Yeah, that's my home position. Plus 6 millimeters. Okay, done. Info load. Here we go. Done. We're going to load. Facing 3. And we're going to run it. And you know what? I can't wait. I can't wait for it to ask me to change my tool out again. I'm so excited for that. I'm elated for what is about to come. Here it goes. Thank you. I'll insert tool number 1. Look, it's done now. All right, we're out of non-alcoholic seltzer. Here we go. Once again, another ride on the Joey B is terrible at machining express. Do it. Okay. Not terrible. I mean, it's not terrible because it's not doing anything. So we're gonna have it run through these first few things. This is so much fun. I'm loving this. I'm having a great time. And it's supposed to only step down like a millimeter. Yeah. I don't know, we probably have one more of these passes to do. Isn't that way too fast? Yes, it is. This is the actual feed rate, and we can slow it down a little bit too once we get closer. But I'm just trying to speed through this process because I set the plunge height way high. Ah! All right, on this next pass, we might get got, as the kids say. Okay, then it's definitely the next one. Here we go! Love this sound, love this sound. Like settings. It does sound kind of nice. There's like some fun harmonics. Do re mi. All right, a little worried about whatever pass is coming up. It's possible and perhaps even likely that the plunge is going to be pretty intense for this. Oh, it's working! I mean, that doesn't sound great. Ah, yeah. All right. I shouldn't have gone faster than that. I should have just wrote it out. Okay. Let's connect to the cutter. Flew too close to the sun, ya boy, Icarus. Just call me Icarus Thickerus. Please don't call me that. Okay. Maximum step down. Multiple depths. Let's go to like a 0.65. I don't know. It felt really good when we did that. And then let's... Oh, God. All right. About to get a lesson here. Hello, Mr. Garcia.
Hi, Mr. Joe.
Oh, boy.
How's it going?
Well, I'm sitting on the couch reading a book. No need to go on the internet.
Oh, all right. Copy that. I was just wondering if we wanted to talk about machining tips right now, since it sounded like you were planning on making some polycarbonate things soon.
That's really crazy that you knew that. Wow, what an amazing thing. Yeah, so...
You did ask me for step files.
I did, yes. So... Yeah, what are your thoughts so far?
Please make your tool stick out less.
I cannot. I tragically cannot do that. It is in all of the way.
Oh no.
Yeah. So to call it, the stream is probably a little delayed. Also, let me move the tool out. Hold on. Hold on. Give it a second. Oh boy.
I have a horrible idea. I am about to propose sacrilege.
Wow.
You could just Dremel off like 60% of the shank.
Yeah, but isn't it like super hardened tool steel?
Right, but a Dremel is an abrasive cutting, not a cutting.
Huh. Okay, hold on. Let me just demonstrate on the stream here. There is no further that this tool can go into the collet.
Do you have a shorter tool?
Yes, but it is also... There we go. I mean, this thing is beefy. The problem is this is also for the Shipoko, so it's for like the larger machine, but this is like as far as it will go in there. I can look. Like I have 1/8 inch tools that will stick out less.
So your problem is your quill isn't very. I guess it's not a quill technically. Your spindle isn't very stiff.
Yeah.
So when you've got that long lever arm, like if you just put that back in there and then just push on it to the side, you can see how much it moves.
Yeah. Right.
And that makes your machine sad.
That's why it was like oscillating or like vibrating at the end there, right?
Yeah, exactly. Because you actually want thicker cuts. If you look at your chips,
Yeah.
When you're going that slow, you get those bigger plastic chips. That generates more heat in the chip, and it makes the plastic closer to melting.
So let's do
for the plastic, turn the speed all the way up and go as quick as you can to keep the heat out.
Okay. Let's do an 1/8 inch bit then, and see if we can go a little faster.
Yeah. Are you all the way up on your spindle speed?
Yeah. Yes, I am.
Okay. That was the end of my useful advice.
Yep. All right. Well, let's put this into practice. I'm gonna change the collet out because it's a different one for different sizes, which is a fun thing. And we'll try the 1/8 inch bit.
Oh wow, that's an adventure.
When you send me chunks of titanium and you're like, you could try machining these, I'm like, I don't know that you fully understand the situation here.
I'm not sure I fully understood the situation.
All right. Well, I'm gonna get to work on this, and if you see me commit more than 10 machining crimes, you may call again. But
try keep score on a whiteboard.
yeah, no fewer than 10 machining crimes will warrant another call, unless one of them is a felony.
Alright, sorry to bug you.
No, not at all. All right, we got a new tool in, and we're gonna try this again. All right, I'll talk to you soon, Charlie. Okay, so we're trying with the 1/8 inch bit. It's still a flat end mill. We're gonna have to. Gosh, I am so excited to remeasure the tool length. God, golly, so excited. Now we need to redo this because is the facing operation? Yeah, we'll just change the tool. 1/8, 1/8 inch, flat end mill. There we go. 1/8 inch flat end mill. Good enough. Excuse me. Now we can redo this operation and we can go a lot faster. Spindle speed still has to be 10,000. Cannot go faster. But we can drive the machine faster. So the feed rate could be up to like, I don't know, 2,000, like 2 meters per minute. That still feels pretty slow. I don't know. We'll see how that feels. And then we can probably do a deeper cut with this too. We'll go up to 0.9. And then the, what is it called? The feed height from top. Oh no, the top height, stock top, that is going to be 0 now because we've already ground down a bunch. And I don't know, we'll see what this comes up with. Yeah, that looks great. Let's try it. So post-process, here we go. 101. 3 facing 4. Love that it's taking so far 4 attempts to do what is maybe the simplest operation. All right, load, done. The home is probably going to be the same. I guess we can check it. Load new, facing 4. Oh, come on. Why do you make me do this? I like click the wrong button and it's like measure your tool length, and then I can't back out and be like, no, I didn't want to do that. Okay, rapid position. Current offset +6. Yeah, that looks right. And then we'll just do this one more time to double check. Yeah, that also looks right. Great. Yeah, I'm counting it. Oh gosh. All right. You ready? Run it, boy. Measuring tool length shirts. Jared, let's do it. Speaking of, if you want a BPS shirt to help me buy new, I don't know. Honestly, you shouldn't want to purchase me anything after this stream. But if you feel so inclined, we do sell shirts, among other things. And if you want something, you should talk to Jared Bass in the chat. Jared runs the merch stuff now. All right. Please send good machining vibes. Please send those vibes my way. I desperately need them. All right. Okay. That sounds okay. It doesn't sound good. Gosh, there's this awful hum. It sounds so bad. So bad. Look, I'll say this. I have never gotten this machine to sound better than this. I've never gotten the machine to sound better than this. Hopefully that's a little more tolerable. Oh my, are you kidding me? You're kidding me. It's not even, I'm gonna lose my mind. It's not, okay, so the step over is too large because it's leaving all of these things on there. Oh. All right. I'm gonna lose it. The step over is gonna be 2.9. Great. Right? There we go. It's horizontal space between passes. We're just gonna lower it a little bit because I'm leaving a bunch of crap in the middle. I'll go to 2.8. All right, facing operation number 5 for the same thing. Here we go. You know what I need? I need another non-alcoholic seltzer. That's what I need. That's definitely going to result in better cuts too. I just know it. Stop. All right, let's clear out just a little bit. Gosh, it wasn't terrible. Oh, you know what? Should we? No, the depth is fine. I'm not messing with it. We're just gonna do it. It has to be done. We're gonna load a new file, facing 5, and we're gonna run it. Let's do it. Let's do it, buddy. You and me. Oh, thank you. I love changing the tool. Thank you so much, machine. All right, so this first cut should be really easy. That sounds very nice, and it's only because we're not making any real cut. However, we are cleaning up all of the nonsense that we left behind. Alright. Moderate success. I just want everyone to prepare for the eventuality that this is going to start to sound really bad pretty soon. I'll let you know. Got one more pass. Alright, folks. This is about it. Get stoked for the sound. Oh, wait. There's one more. Okay. We're almost there. Get stoked, though. Around a lot of chips too. What size collet do I have? Like the native size is 1/8 inch, so there's no transition, there's no step down or step up on the bit. All right. Okay, I'm not feeling good about this, but I'm not feeling terrible. There are no war crimes. It's just like light treason. the worst thing I've ever done. Have you heard of the new metal band called Crime Against the Machine? Getting there. All right, I've decided I need another seltzer. I'll be right back. I've got a new flavor of generic grocery store brand seltzer, just regular seltzer water. All right. This is the last pass, and then we can do a contouring operation and then almost be done with this sheet. I am seeing some things in the comment about me being on the claw wave, and that's incorrect. This is regular seltzer. I mean, it's a good guess, but it's not. There's no. It's just a regular seltzer. I have to say, I mean, getting it started was bad, but this moves a lot. This moves a lot faster than when I was trying to machine aluminum over the summer. Oh yeah. Okay. Look at that. I could go pro. Oh, it's very smooth. Okay, so the next thing that I want to do is using, oh, that feels really nice, is that using the same tool, I'd like to machine out all of the holes. Oh dear. Okay, what is 1/8 inch in millimeters? Ah! It's 3.175. There's a 3 millimeter hole on this. Just kill me. All right. The facing operation is done. Let's make a new one. It is a 2D contour with a bunch of step downs. Right? Yeah. It's a 2D. Oh, and not of the outside. It's of this, and this, and this. It's of all of these things. Will this work? Do I have to select the bottom of that? Stock contours. Boundaries of the defined stock. I don't think I need that. And I think it's going to use the same basic settings. Height, passes, roughing passes, multiple depths. Maximum roughing step down, finishing step down 0.2. I mean, I can probably just go for it. No stock to leave. I mean, let's see what it comes up with. Dude, look at this. This is perfect. It won't go in the other holes, though, because the tool is too big. 1/8 inch. Okay, so we'll do this and then move to a smaller tool, I guess. Yeah, what's the worst that could happen? We'll do this. Thank you, Sean. Joey, sit up. You're going to give yourself back pain. Stay safe, and stay well. Thank you, Sean. I'll sit up. If I lower my chair, I have to sit up. Well, what do I do here? I mean, it should be... I guess I could do a hole. Let's just do these. Let's focus on this, and then we'll go from there. Why is it mad? Not machine would cause a collision. Right. Do you think that I can... use a bore for the large and drill with pack for the small? Okay. Screw it, man. I mean, what's the worst that happens? As I have said several times tonight, what's the worst that happens? Contour 1. Definitely spelling contour right there. Don't want any questions about that. We're going to load a new file. And this is just going to get out those sort of step downs. Run. Do it! All Joe cares about is hole size and tool length. That's about right. I don't even know what to say about that. Alright, let's get you right there. Oh, I gotta hurry up. Oh, because we're going from the stock top. Okay, hold on. I need to pause this. I need better lighting. This is actually a really common machining practice. Having good lighting for your machining operations it's really common practice to optimize for this. All of the best machinists do it. Great. Resume. I swear to God, if you measure the tool length. Bro, is this thing doing anything? I don't think it's doing anything. Oh my God, are you kidding me? Alright. Oh, I set it to the wrong one. Alright. It has to be in there. I get it now. I understand. There we go. All right, let's try this again. What's the second contour now? I'd like to take this time to commend anyone who chooses to watch this content. By choosing to do this, you are, well, okay. Anyone who chooses to watch this content who has experience machining, by doing this, you are willingly subjecting yourself to some really, something really awful. Alright, measure the tool length. It's also common practice to have, okay, I need to find a new plug for this. Alright, yes. Hey, it's not bad. This is working pretty well. Wow. I'm leaving a little bit in the middle. That's okay though. We're gonna drill through that later. Oh, Sleeve Dog would like me to inform the chat of the number of G's that Ava and BBR pulled when hitting the ground. So we did a little math on it, or someone else in the Discord did a little math on it last night, and it turned out to be somewhere between 1,000 and 2,000 G's. We went from 80 meters a second to 0 meters a second over the course of about 2 meters. And that's a really big generalization, but it's a lot. Awesome. Okay, I did that. We're moving right along, folks. Next up, I need... what's the other bit that I have? I have 1/8 inch. .063. What's .063 in inches? It's not 1/8. 16th? .063. That's 16th, right? 16th inch? Let's change out the tool for 16th inch. This will be enough to get us through. And then we're going to have to go back to 1/8 to cut the part out. Yeah, I said, so sorry, the machine was running, but we pulled on the order of like 1,000 to 2,000 G's with Ava hitting the ground. And like, for Ava, that's nothing. If a part weighs, let's say 10 grams, and you pull 1,000 G's, you're only weighing, 10 kilograms? That's like, it's only feeling the force of 10 kilograms. 1,000 G's for small parts is nothing. I mean, you're I don't know, a penny, when it hits the floor, must do like 1,000 Gs. Or it must do like a crazy impact. For small object, it doesn't really matter. Okay. This goes here. Then we'll get a 16th inch bit. Oh no, that's the wrong one. There. That goes in here. Sixteenth. Tighten it down. Clean it off. We'll create a new thing. Okay. We'll say screw this contour because it's done. Select 16th inch flat end mill. And 10,000. 10,000. We can probably go, oh, that's pretty slow. Do like 1,000. And then whatever the depth is, I don't know, it felt fine before. So then the geometry, here is where it is a little interesting. I feel like the geometry, we want to go all the way down to the bottom on each one of these, right? Like this. We want to get all the holes here. I'm pretty sure this is what I want. Yes. And I think this will maybe be fine. Small concern. Otherwise, not big concern. Small concern for sure, though. Post-process. Here we go. This is contour 3. We're really cooking now, folks. I'm in the flow. I'm not crashing the machine every time, just like every other time now. I'm gonna leave this open for now, and I'm gonna switch out for safety glasses because I want to get shots that don't have reflections in it. Alright, it wants a new tool, and like, frankly, same, LOL. Lamau. We're just gonna let it do its thing here. And at some point it will actually cut that hole. This is excruciating. Please just go in. Alright, it's definitely the next one. Oh, it's because it's a contour, not a hole operation. Alright. Nope. I'm learning things. I'm learning how to do stuff. We can do this better. We're going to do a bore operation on all of these. That's what we're going to do. Okay? It's a bore. The tool is a 16th flat. It's carrying over the things. And now we're going to select the geometry. Boom, 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 bada boom, pow. Boop, bop, bam, bada boom, pow. Real ones, no. Okay. I don't know. What's the height? Top height is whole top. How about top height is stock top, just as a treat? Oh. Sure, clearance height can be that. Face. Yeah, that feels good, right? Loving it. What the... Okay, we need to select more holes, I guess. What happened to all of my holes? I selected 12 of them, and yet you only chose several of those 12, and not all of them. Why did you not? Will you tell me? 1, 2... Bing, bang, bop, bada bop, boom, pow. What happened here? Does anyone know? Let's select stuff. Like, will it do... Oh, I hate using this with a touchpad. Will it do that? No, it will not. Why not, buddy? System library setup sheet viewer tool library release. What? Can we not do that? Can we not have whatever that is? All right. Well, that sucks. What do we do, folks? Model top face, avoid cutting material. Clearance height lower than the top height. It might see the other holes as already drilled and try not to recut them. Maybe it's that. Maybe for these. These are... I have that operation. Let's say that goes after this. There. Yeah, maybe it doesn't like that. Let's try this. No. What does this warning mean? Online system library setup sheet viewer tool release. This is entirely unhelpful. Rain Can says, finished my test and I bombed it. Let's go. That's a bummer. I guess we can do the contour. Can we not retract after that, though? We could do the contour if we don't... John, is your entire house watching this? Where are you? Are you in Boca Chica or are you in Florida? All right. Retract height. Model top. Offset 1. Fine. 7. Oh my god. Top height. Trevor says, I miss us. I miss you too, buddy. What I miss most of all is the ability to not do this. Okay, can I just have a contour that doesn't pull up every time? Keep tool down! Avoid retracting when the distance to the next area is below the specified stay down distance. This maximum stay down. Tool paths will make a cut and reposition for the next cut. If the distance between the positions is greater than the maximum stay down value, The tool will retract between cuts. This seems extremely dangerous.
The rapid motion violates the workpiece.
Oh. Nope, never mind. It's not that dangerous. Okay, the maximum stay down distance is going to be 10 millimeters because I'm just a super duper wimp. And the lift height is going to be 1 millimeter. And we're going to try that. Loving it. Living, I'm living, I'm laughing, I'm loving. I'm just laughing and loving all over the place. All right, post body yada 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 yada. Here we go. Contour 4. Going off the rails. Joe, I haven't seen you take a drink since I started watching. I am going, I don't know, somewhat slow here. Okay. Run. Do it. Do it to me, Daddy-O! Alright, bore me up. Please. Oh, yes, the tool has been changed. Yeah, that's it. That's what I want. Nice! All the way through! This is going really well. What's your camera setup like, says Adam. This is a Zcam E2. So I have a 24 to 105 by Canon on it, and an Atmos Shinobi for a screen, and then I have a small rig wooden handle on it, which is really nice. And it's awesome. It shoots 4K, 120 frames per second. It's like the best. It's like a Red without paying for a Red. Have I entered into Inspiration 4? No, I have not. I am so stoked for all of the people who want to go to space, and I am not really interested in going myself. There are also people who are way better to like represent humanity than I am. I love building model rockets, but I don't know. We have plenty of white dudes in space. I feel like pick someone else. I'll go at some point, but not on this. All right. It's going well. Ricky entered. I mean, I'm stoked for everyone who's going. Or everyone who entered. I think it's certainly worth a shot. I just like it still feels very dangerous to me, and I'm a little scaredy cat. Cole says, "What up, Cole? Just joined. You probably answered this already, but what part are you milling?" Cole, this is for the avionics bay. So for my level 3 certification, this is the avionics bay, and there are 2 sleds that hold a telemetrum by Altus Metrum and then Ava. So right now we're milling the telemetrum sled. It's this part right here, but we want to make it out of polycarbonate instead of PLA, so that if it fractures when we land really hard, it's a little less unfriendly to the computer. And you know, truth be told, it's just a good exercise for me to be milling stuff anyway, because I don't do it very often. Okay, excellent. That's great. The last thing to do here is to cut it out, I think, right? Can do a little vacuuming. We also went right into the wasteboard, which was the goal, and that's good. It's actually way more see-through than I thought. I thought it wouldn't be quite as see-through after I milled it down. So this last thing is going to kind of suck. We're going to switch back to the 1/8 inch bit. And now I'm feeling a lot more comfortable with this whole setup. Folks, if you're wanting to stick around for if you need entertainment for the next 2 hours, I promise you, this is happening. We're sticking around until this thing is done. And I have this to do. We have one more operation on this, and then we are doing a second one. And the second one is even a little bit more complicated as a treat. Okay, here we go. Take this off. Oh, that's the wrong way. I do the wrong way every time. Boom. Okay, 16th inch, goodbye. This is the 1/8 inch. And we're going to do a massive contouring operation from the stock top to the bottom. We kind of have to go from... Oh, that's the wrong direction. We kind of have to go from the stock top because I didn't do a very good job facing it. That's enough. I didn't do a very good job facing it, so there is not a lot of leeway there. Does any of this make any sense to anyone? All right. There's one last operation. It is a 2D contour. We could just use this, frankly. I mean, it felt pretty good when I did it before, so let's do it. Contour selection is that. The bottom is the bottom. I mean, that worked before. We're doing multiple step downs, and we're just cutting the part out. At some point, oh, and the part isn't going to slip. Oh, this is dope. Oh, I'm so stoked. Okay, great. The part isn't going to, we can also do way more of a step down on this. Like 0.5 is fine. So, yeah. We don't need that much of a step down. That feels way better. Let's do it. Post-process. And okay, what I was worried about before is that we don't have tabs on this to keep it as part of the stock material, but we don't need them because I yeeted that MF right to the base. So it is stuck no matter what I do. And I'm slightly concerned about getting it off. Here we go. Run. Probably put this back. Did I set it for stock top? Oh, great. I love changing the tool. Great. Love it. Let's go further back. More interesting angle. Hey, not bad. Okay, this makes sense. That's a chunkier cut than it should have been, but oh well. You know what? Screw it. Here.
Joey B. ASMR.
We're all out. I'm gonna get another. Almost there. I know you want the RPM down. Why don't I just do the feed rate up? I promise you, this machine never ever sounds good. No part of this machine ever sounds good. I have done a bunch of parts on this, and it never sounds good. It does sound like we're at the bottom now, though, which is great. I'm gonna let it go all the way to the end. It's done! We're halfway there. We are 2 hours into the stream and we're halfway there. I guarantee the second half is going to go by a lot faster than the first half. The first half we had quite a few transgressions. You know what we can also do here? Let me grab a. I can grab the deburring tool, but that's probably too intense. Honestly, I think like this is probably enough, just to like get some of these burrs off of there. But this looks pretty good. Yeah, dude, this looks pretty good. I'm like, I don't know, moderately happy with it. That's what it's going to end up holding right there. Let's do the other one. The other one is a little bit more tricky. So we have a big old chamfer right in the middle of it. So that's going to be a fun little treat for everyone. And by treat, I mean nightmare. And by everyone, I mean me. And anyone who chooses to watch this stream. Oh my god. Alright, let's get rid of this. The manufacturing is done. We don't need this. Goodbye. Now, we can insert sled Ava. Current design. Boom. Bada bop boom. Pow. Great. 30 degrees over, so it's flat. Boom. Bop, bam, bada bop, boom, pow. I cannot get that out of my head. It's fine. We can keep things relative to that. Let's get rid. You know what? Frick it. Let's use the same setup. Yes. Okay, work coordinate system. Let's talk about it. Because it's not correct right now. Let's just get rid of it. I'm done. Oh, wait. No. I forgot. I did rotate this in CAD. Move, or in the design phase, rather. Boom. Bop, bam, bada bop, boom, pow. Sorry, again, I can't stop. Move. Put it there. Yes. 90. It's just going to make my life easier if we do it that way. Manufacture, home, and then front. If we look at the coordinates, like that's correct. And we've got essentially the same setup. Yes. Okay, model is this. Sled Ava. Stock. Oh, yeah, stock point. Work coordinate system is a stock point, and it's going to be the back one here. This is the most important part, is getting the home position right. And now that I have set that, let's go back into jog. Oh, great. I can't wait to measure my tool length. And I guess we'll just face it all with the 1/8 inch. We have to change what the home position is because we're trying to just not collide with the other thing. We're doing it all out of this one block. So let's... I mean, it doesn't matter that much. Great. I mean, we'll go up one and say that's the stock top right there. Set 0, 0 all, done. All right, that's done. And then we set our home right there. Yeah, we set our home right there, and then let's talk about this facing operation. Yes, clear the things. Tool, stock selections. We're going to face down to this. And this. Stock contours. Is that what I want? I don't think that's what I want. I mean, sort of, but like, what if I just face down to the whole thing? Is there a point in doing this? I could do adaptive. Would that work? That chamfer is really gonna mess me up. This is great. Whoa, we're halfway there. Whoa, Joe Barnard chair. Thank you, Lavi. 154. That was great. That was really good. Yes or no? Need an answer now. Jared, is this about something in the chat? Jared, I'm a little worried about giving a yes or no answer with no context. Can the chat answer? Oh, hold on. There's more text. No, merch. Jared, I still need more context. Like, yes, we do have merch. Okay, chat needs to answer yes or no. Merch. Gosh, if only I... Yes, I think so. Well, I'm not entirely convinced, Jared. I mean, it's the softest possible yes. Yeah, limited edition. Yeah, absolutely. Absolutely limited edition for the stream. Yes. An enthusiastic yes for that. Okay. Folks, what are we going to do here? I need a... I mean, I guess we could do this too, right? And it just gets everything down to that height. Yeah, let's do it. Let's screw it, right? We know that this has worked before. It won't be super pretty. It won't be that fun. We can probably change the step down to be 0.7. I think it's probably friendlier that way. Let's do it. Process. Jared is cooking up something real good. Oh my god! It's literally done! Listen, everyone, I'm buying one right now. Medium. Go to the link that Ricky just put in there. I'm buying one. Remember to measure your tool length. I'm buying one from my own store right now. I think I'm probably losing money on this. Yes, I will subscribe to BPS emails. Updating my cart. Flat rate shipping. It's a shirt. I've been trying to buy like a lot of new shirts anyway. But yes. Purchase. Done. Order confirmed. Excellent. Don't delay. Buy today. All right, here we go. Oh, sweet. A new order has arrived. I wonder who that could be. Wait, stock depleted? Jared, we have to have more than one stock in there. All right. We're doing the new operation. Desktop. Mech 3. Ava. Face 1. And here we go, right? Let's do it. Load new file, Ava face 1. Run. Go for it. Don't forget to measure your tool length. Love it when it asks me that. Absolutely love it. And no part of me gets very frustrated about it. Alright, Godspeed. Whoa! Easy there, buddy. Going real fast. Ben Maitland, I think you're right. Like, the step over is still too high. We get these little strands that we probably shouldn't, but it's too far into the operation to really care about it. Okay. Excellent. Very nice. This is awful. There's a lot of material to clear. Alright, there's a lot of material to clear, but we're well on our way. So the next step, gosh, this feels so cool. The next step here, let me get a nice bit of B-roll. You should always shoot, I mean, if you're just getting into filmmaking or YouTube videos or anything like that, you should always shoot way more B-roll than you think, and then you'll learn to dial it back. But you will regret it if you don't shoot enough, and you won't regret it as much if you shoot too much. Okay, here we go. So now we could do a boring operation, but that's not really what I want. What I kind of want is to figure out how to deal with this. Let's do another face. Excuse me. Can we duplicate this? We can duplicate. Great. And then the contours are just this. Can I face that down to the model? Oh, is that gonna work? I don't think it is, man. I kind of think that we're gonna plow into the model if we do that. Actions. All right, show me the money. Show me the stock and then clear it away. All the way. Don't show the toolpath. Right, I get it. But like, show me this one. Wait, I don't think this is any different. I don't think we go any further down. Maybe what I want is a contour. Yes, missing references. Can I do that? No, that's not what I want. I want adaptive clearing. Let's try that. This. Clear me out, okay? Try it. Yes. Geometry. The heights are probably fine. We do want multiple depths. And because it's adaptive, we can go a little lower, but it depends on the step over. Oh. I kind of feel like 2 is the maximum that I'd want to go. No stock to leave, because I don't care. And then the tool is the same thing, 16th flat. Let's try it. Yeah! Wow, that's probably... kind of intense, don't you think? Okay. The minimum cutting radius can be 0.3, and the stepping... Yeah, you know what? Screw it. Let's try that. That does look better. I don't know, man. We have to clear it one way or another. Does Charlie G work for BPS? Maybe he can do the propulsion parts and you can do the control. I do appreciate the question. Charlie definitely does not work for BPS. Charlie has a very cool job. He is currently designing engines that will actually put things on the actual moon very soon. He's at Agile Space Industries and killing it. And ya boy is trying to get to like 10 kilometers. Please do the whole top face with this op. Do you think I can do that? It's only 2D adaptive though. Let's try. Can I add these? Will it do the chamfers? Yeah, I don't think it will, man. Oh! I don't think it's gonna do those. It's not 3D adaptive, it's 2D adaptive. I feel like let's deal with the chamfers later and not do that. Oh. Gosh, this is so hard to use with the trackpad. Just total nightmare. Yes, I want this, I want that, I want that. I mean, that's sort of more of a contouring thing, but like, if adaptive will get it, let's do it. Adaptive will not get it. I don't. 3D adaptive, choose the outline. Neil, I'm sorry, man. I am not an expert. If you are feeling pain from watching this, I advise that you stop, because it's not going to get a whole lot better than this. I'll try 3D adaptive if you want. This, I mean, let's just see how that shows up. I just want to see how like the toolpath looks. Wow. It's not terrible. Wow, it really gets everything though. This is a crazy operation. I guess we could do it this way. All right, well, screw it. Let's do it this way and see how it turns out. How about it, you know? I advise you don't watch my rocketry attempts. Neil, that is so respectable. I love it. We all have things we're terrible at, and this is it. For me, this is it. All right, well, let's try this. Maximum roughing step down. Should we just try it with the stock settings? I guess it's worked okay so far. Reduce the box point to the material and it won't cut over. I don't mind that it cuts over. How close will it come to the probe? It's going far over the edge. Okay, so passes... That I don't care about stock to leave. Lead-ins, transitions. Do I have a ball mill? Yes, I do have a ball mill. Is this the same machine used for the rocket motor test stand? Yes, it is. Good eye. Okay, what should I look at to reduce... I'm a little concerned about this cutting depth, man. I mean, like, the whole thing with adaptive is that you use the side of the mill rather than the end. But... I guess it's probably fine. You know what? Screw it. I mean, it goes way out, but we can kind of afford it. Yeah, let's try it, and then we'll go from there. It's not going to break the bit. It's plastic. It's not going to break the bit. The machine is going to stop. The machine can't do a whole lot at all. It's not going to break the bit. It will stop the machine before that happens. And I have like a bunch of these bits. Ava adaptive 1. And again, the worst that happens is pretty much nothing. We stop the machine and then we revise. I think it's probably too fast. And we will find out very soon. It's going to ask me to change that tool. Boom. It went right in. Okay, let's talk about plunge. Let's talk about the plunge. I want to do two things. I say we increase the maximum cutting radius to like 0.2. We decrease the step down to 3.2. And then for the plunge feed rate, we have to go slower. We have to go like 150. And maybe the ramp as well. I don't know if we're doing ramping here, but the same thing, lead in, lead out, 200. We're just going to accept like lots of slow stuff going on. 3.2 is still too much. I mean, it feels like it to me. Let's do 2.2. That's going to take a long time. If it really feels like we're not clearing a lot of stuff, we can try again. But that's a lot of changes, and oh my gosh, is it a lot of time. Wow. Yeah. This is going to take a long time. I mean, it just needs to be done. If it's a little inefficient, I can live with that. Post-process. Here we go. Desktop. Adaptive 2. Info. Oh gosh, can't wait to measure my tool length. Why not helix in? That's a great question because I hadn't thought of it, and that's the entire answer. I hadn't thought of it. We'll try it without. Done. Load. File adaptive 2 and run. I don't think we lost steps. I mean, we were only going down, so we definitely didn't like lose a bunch of steps. ask me to change that tool. Alright. Cross your fingers, everyone. Cross them. Cross them good. Clearing shouldn't be that bad. We'll see. It's a really deep cut. Well, see, now it's not getting anything, because I think we're clearing from, like, the wrong stuff. So now we're doing like the real adaptive clearing, where we're not plunging into the stuff. We're just using the side of the bit, so we can go a lot faster. And the chips look all right too. Alright, well, this is gonna take a long time. It's gonna take some time. Yep. Well, this is as fast as we can go. All right. Well, so honestly, I'm fine just waiting it out. As it gets closer to the center, the runs will become shorter, and I'm fine just waiting it out because the rest of the passes are going to be actually taking material out, and it will take me longer to figure out how to go from this and then load the new G-code than it would to just wait it out. So let's just wait it out. Let's answer some questions. If you've got questions for me, put them in the chat, and let's do that. So, what about egg earthers? Egg earthers are absolutely welcome. If you're an egg earther, if you think the earth is shaped like an egg, absolutely welcome. You're happy to have you here. What's the rocket with the orange nose cone in the back? That is called... that's called Shrek with 3 E's. Shrek! And I can't tell you why. I swear, like, within a month, you will know more about it. It has had 2 flights already, and it's gonna have a 3rd. This toolpath is so inefficient, I love it. Yep. It's, I mean, that's what you tune in here for. What areas of SoCal are you considering moving to? So, let's see. My family lives a little south of LA, so that's a big factor for me. I also want to be somewhat near to Mojave. The Friends of Amateur Rocketry test site is great. Also, RRS and MDRS. Like, wait, MDRS? Anyway, there's a ton of great rocketry stuff up like north and to the east. I won't be down in San Diego. I won't be up in like Lancaster, I think, is too far north. I mean, it'll be around the LA area, but I don't want to live in LA because LA's kind of gross. Do you use general purpose MCUs in your rockets like Teensy, or actually put chips on your own boards? They are all Teensy clones or Arduino clones or some type of clone. It saves a lot of time to build and like piggyback on those sort of like architectures. So, like, the Signal R2 board is basically an Arduino Zero. The Signal Alpha and main processor for Ava is basically a Teensy 3.2. Honestly, it's pretty much one of those two. Both of those like have their benefits and drawbacks. I have to keep my eye on this so I don't let it run too far. All right. Will you be hanging out at FAR and MDARS a lot then? Yeah, I will. And there will be launches that you can come to. I mean, you know, COVID sucks, and like, don't come to any launches right now. But I'm not moving out until probably the fall. But when I do, and like, you know, once I get that I mean, once COVID like calms down in general, I would love to have people out to launches. I think it'd be really fun. We could do like meetups and stuff. Yeah. So, do I enjoy the experience of an FRC team? Do you still mentor them occasionally? Free with Fire. Yeah, so I was on team 2888 in high school. The Beaver Bots. I don't think they have a team anymore, which is kind of disappointing. Okay, hold on. I gotta keep my eye on this. My plan is next... I would like to start mentoring... I've never mentored a team before, but I would like to start next winter. Once I'm out in LA, like... so a thing that has been missing from my life a whole lot is working with a team, working on a team of people, and regardless of whether it's like mentorship or otherwise, it sucks to work alone all the time. And I think mentorship for a first team, it would be like really fulfilling for me and just a lot of fun. So I'd like to do that. If you end up doing active control on high-powered rockets, how are you going to compensate for the changing center of gravity and changing mass to the burning motor? It's garbled that. Changing mass due to the burning of the motor. Well, so Dino, it's pretty easy to compensate for the changing mass of the rocket and changing moment arm, and I mean even the changing inertia, like all of those things are easy to compensate for if you know where you start and you know where you end, and you can measure where you start. Like, you can measure what the rocket is like at launch, and then you can measure where you end. You can measure what the casing feels like empty, and then, you know, approximate how much extra coke will be inside there or whatever. Okay, hold on. A little worried about this. We're about to take another really big plunge. So you can, as long as your, you know, guidance system takes that into account. I mean, that's how real rockets get to space. You know, they have crazy, huge changes in their mass, huge changes in moment arms. There's an interesting problem, that I'm working on with the Level 3 rocket, and I'll talk about this in the video that's coming out in like a few days for BPS. Oh my gosh, it's so close. I'll talk about it in a few days. I have a roll wheel, a reaction wheel. Okay, cross your fingers. Alright, we have to go faster. This is awful! There's a reaction wheel on the Level 3 rocket, and there's an inertia dumping problem. It's very hard to describe, but there are some interesting control problems that you get into when you have a significant propellant mass fraction, because the reaction wheel is storing momentum, and as your mass changes, your potential for momentum changes. It's hard to describe, but if you store a bunch of momentum when your mass is 22 kilograms, and then your mass suddenly changes to 14 kilograms, you are no longer storing. You can't keep storing the same amount of momentum because it's really interesting. This is awful. All right, almost done. There we go. Now we're into the adaptive part. And we can go a little faster with this. Okay. People were suggesting some limited edition L3 merch. I love it, Jared. I'm super into it. So, Jared, we're having, Jeff said he'd do it. So, Jeff Barrett is going to be working on the design for the L3. And I'm really excited about it. I think he's going to do a great job. Okay. Charlie with the if you know, you know. Charlie is right. So when I talk about the momentum dumping problem, Charlie is the one who pointed that out to me. So you should assume, I think you can safely assume that when I say something that sounds really complicated and you're like, whoa, that is the case, you should assume, I don't know, 7 times out of 10 that it came up in a conversation and Charlie was the one to be like, have you thought about this? Joe, why don't you vlog? I have plenty on my plate as it is, and I think vlogging would be a lot of work. I also I would rather have the content that I make focus around the work that I do rather than me. Okay. Are you still in Tennessee? Yes, I am, in Nashville. Have you ever considered bringing something like Scout E to an NAR competition or something? I feel like the brains of the rules people there might explode after seeing Scout fly and land. It would be fun to do an NAR launch. It's just harder to coordinate schedules. So there are very few NAR launches right now, regardless of like being in my area or not because of COVID. But even when COVID wasn't a thing, Tennessee has a hard time finding good launch fields. Okay. Where are you that it's sunny? Oh, it's not sunny. These are video lights. It's dark right now. It's 10 p.m. in Nashville. All right. Loud CNC noises. What's the status of Launcher 1? Ricky, you should know. But yeah, Launcher 1 is still happening. Ricky's now making the plane. And fingers crossed, man. All right. When you get to space, would you try to land using an engine or by parachutes? So when I do the space shot, which again is, it's not anytime soon. When I do the space shot, I will land via parachutes, not via propulsive landing. You have to carry a lot of extra mass to propulsively land, and when you're doing something like a space shot, the margins are incredibly tight, and so not only is it like technically difficult to propulsively land, but physically difficult as well. Okay. What's your favorite number in the alphabet? I don't know how to answer that. What happened to your Falcon rocket? It got very complicated to build and operate, and I don't know, after 2 videos with the second one being a failure, I was like, this is not worth the time. Maybe I'll do one in the future, but not anytime soon. Okay. What are you doing for a living? This is what I'm doing for a living. Arsenio answered that. But yeah, I have a bunch of people who support the project on Patreon. They pledge a little monthly amount. That makes a huge difference. I do very silly streams like this where I machine things or stuff like that and people super chat. I sell merch, so you can buy this stuff. I know that you weren't asking, like, how can I support you? But if you're curious, it comes from a bunch of different places, and it's weird. I don't know how long it'll last, but it's very fun while it's working. Okay. SNR Tech Bite, shameless plug. All right. Are there any? Someone asked why don't you answer my liquid rocket my liquid rocket questions? I'm not making a liquid rocket anytime soon. There are a lot of people who are really good at that stuff, and I learned by experimentation. As you've seen tonight, I've learned a lot by plunging the machine into the material several times. Learning by experimentation is great, and it's a lot of fun, and it's the wrong approach for liquid rocket engines, where you can easily get yourself really hurt really quickly. So, propulsion isn't really my bag. What's your favorite species of banana? I like yellow bananas. BPS album when? I'm making one. I swear I've said this a lot, but I now am actively making one, and maybe late spring. Favorite dumb shiggles project? I don't know. A lot of my projects end up going like pretty hard. I don't think any of them are like sort of one-offs. Favorite kind of bread? My favorite kind of bread is the Bowman bread, but a close second is sourdough. All right. What kind of end mill are you on? This is an 1/8-inch end mill right now. Release on vinyl? No release on vinyl, sorry. Okay. Calls himself Propulsion Systems, but hates Propulsion Systems. SMH my head. Will you be able to download MP3s of the album? I think so. I'll probably put it on Bandcamp or Spotify or something. How often do you launch in Huntsville? I've only had one launch in Huntsville, and it went screaming into the ground. Huntsville's really cool. I don't go there very often to launch, though. Shrek or Yellow Boy? I prefer Shrek. Alright. Can I send you baked goods in the mail? I'll have to pass on that. I'm also quite gluten-free and have like 1,000 food allergies, but I appreciate the sentiment. The camera quality is hot. What are you using? Mike, this is a Zcam E2 Actually, yeah, you can see it in the shot. This is a Zcam Me2. It's awesome. It's really good. Oh, wow, this is super working. Yeah, so it's a Zcam Me2. I have had it for a little over a year now. It shoots in 4K, 4K up to 120 frames per second, 1080 240. It shoots in it's not a RAW format, but they actually 4K up to 160 frames per second. They keep updating the firmware. Essentially, Zcam is like a Red, but if Red was a little bit of a sketchy company. So you're paying a lot less for really, really good quality, but you're also taking a slight leap. Is it me or is this toolpath inefficient? It is not just you. It is all of us here thinking the same thing. This toolpath is extremely inefficient. Okay. Are there plans for purchase of your Launchpad? I'm currently working on a smart Launchpad variation and banging my head against the wall. Okay, I will say this. This is directed at every single TVC project. Stop working on the Launchpad. My God. Stop working on the Launchpad. You're way overcomplicating it. Every single person. All you need is to tap leads to a battery on a rail and you're good to go. The complicated part of a TVC project is the flight and the rocket. The Launchpad is awesome, but especially when you're getting started and you don't have great reliability with the systems that you build, putting a ton of complexity in the Launchpad is shooting yourself in the foot. Okay, sorry. I'll get off the soapbox here. Okay. Let's see. Holy cow, you're still screaming. Yes, I am. I am as surprised as you are. 1 second. Let me grab a towel. I think that will help the vibration on the mic. Gotta swap out the batteries on the camera. My favorite part about machining is when I accidentally machine the tip of the vacuum. That's my favorite part. Alright, that should help audio a little bit. Yeah, this toolpath is stupid inefficient. We're gonna be here for a while. Oh boy. Alright, I'm gonna go to the bathroom, and I'm gonna get another seltzer. We're really turning up tonight. And that's that. I mean, you'll just have to enjoy the sweet, sweet sounds of... Yeah, and then I'll come back and I'll answer more questions. So if you want to learn more, stick around, and I will be right back. And I'll just let this run. Are we doing the chamfer? Ooh. Yeah, I think we're doing the chamfer. Oh, well, no, not really. Okay, we must be machining the chamfer out of that. Oh yeah, okay, cool. I think we're doing part of the chamfer soon. Okay. Oh, here come the holes. Oh, and that hole is sunk in IIRC? Yeah, this hole... No. Okay, that seems sus. That seems large for the hole. Oh! This seems large for the hole. That's the right hole size. What are we doing? What are we doing? This is the 3D adaptive. Gosh, I guess... What's the diameter? Okay, let's look at this. What's the diameter? It's 1.75 radius, 1.75 times 2. It's a great example. 3.5 and 1/8 inch to millimeter is 3.1. So, like, I guess... Dude, that's larger than 3.5. Are we using the wrong bit? Oh god, are we using the wrong bit? Oh no! Oh no! Oh no! Oh my hate this. Okay. Well, here's a friendly reminder to everyone. If you previously used a 16th inch bit, you should... Oh, my God. I hate everything about this. It must not exceed, what is it, 99? Optimal load. Fine. Oh, why? 2. That's way too big. So, yeah, please change tool. You know what? I got. In the end, it was me who got about changing the tool because, oh my God. Okay, we should start this from the model top. Yeah, I guess we should start this from the model top. I'm going to... Okay. It's possible this can be salvaged, but it may look slightly weird. And... okay, if... Right now, do some math with me. It thought it was clearing... it thought it was clearing a 3.5 millimeter hole with a... what is 16th inch? I'm going to do it in 1/16th inch to millimeters. 1.5 millimeter bit. And so for that to go around a 3.5 millimeter hole, it's kind of... I mean, I think we're boring out like a 5 millimeter hole there. That is not the end of the world, and I can prove it. It's not good. I don't like it, but it's not the end of the world. Hold on. Okay, so Ricky texted me brass inserts. Look. What is important here? I mean, at this point, like, I feel like it's less safe to fly this. What is important is that this can't go through, and that's true. We didn't cut all the way through the material. I think it's salvageable. This feels like in KSP when you get stranded with no fuel, but you have some RCS, like monopropellant, and you're like, all right, how do I get home? That's exactly what this feels like. So if we do the same 2D adaptive, this is batshit. Okay, so I think this is still fine. It just is it's gonna have a couple of parts that are overcut. Like this section here and this section here are gonna be slightly overcut, and we're not gonna be able to chamfer them nicely. I can do that with an X-Acto knife. I can do it with a piece of sandpaper. Loose tolerance hole. And the best part is it's not even a full bore. Like it didn't step all the way through. I think it's okay. It's not good. And again, I don't like it, but I think it's okay. Let's go model minus something for the top height. We can measure this. We can absolutely measure this. Let's go to model minus 2 for the top height. There's crap everywhere. Model minus 2 is the top height. You do model minus 1.5. 1.7 is the top height. Because we've already cleared out so much. It's going to have a hard time with those holes. But we've already cleared off a ton. Like, that does kind of look... Oh, then it's not going to get the chamfer. I kind of don't care. Like, I'd rather just do it myself. I think this will be okay. Oh, and it won't even do the hole. That's fine. I can do that as a bore after. Great. Love it. Let's do it. Post-process. Okay, adaptive 3. I'm taking a risk by starting it this low. The risk is calculated, but man, am I bad at math. That's my favorite saying. I took a calculated risk, but man, am I bad at math. All right, let's do it. We're finishing this. It's getting finished. We finish the jobs we start, right? That's rule number 1. Safety's rule number 1. Okay, listen to me as I read the gospel to you right now. Insert tool number 2 and continue. Oh, ladies and gentlemen, what do you think tool number 2 is? It's an 1/8 inch flat end mill. Wow, great. I would never be so cavalier as to reject this tool change prompt. Black screen? What happened? Oh, is the camera dead? Hold on. Stand by. Wow. Thank you, chat. Hold on. Working on the black screen. It came up. It's gone. 7.1 volts. We have enough. Is it back? Okay, it's back. I think it's just a little loose. Listen, chat, absolutely spam me if that comes back again. I think I need to replace my HDMI splitter. Okay, as I was saying, I would never dismiss this dialogue that says tool change required. Every time this comes up, I'm always extremely serious about it. I don't want to hear anything about how I wouldn't take this seriously. Okay, with that out of the way, let's do it. All right. This is us plunging into the model a little lower than we expected. That's okay. I mean, it just means that our toolpath is more efficient than we thought it would be. That's one way to look at it. Yeah, so this part is just going to have this bizarre little step over on it, and it's going to be a little ugly. I will say we're making much faster progress than before, and that makes sense, because we're taking the appropriate sized cut out of, each bite. Also, you guys want to see something cool? Look what I got. This is a sun sensor from a real clean room for real satellites that never got used. how tiny that is. So, right there, that's the actual sensor. It's covered in Kapton tape right now. But it's used for attitude determination in a satellite. And then on back here, there's a bunch of control stuff. You'll see it's all potted, it's all conformal coated. Yeah, there you go. That's a fun little treat. And I am, like, pretty sure, according to the person who gave me that, it's like $2,500. And I don't think I will ever use it because I am too afraid. Alright. Ooh, this is cool. I have a bunch of real solar panels from some European satellites. That's cool. Okay, hold on. I did get another seltzer, but I left it in the other room. 1 second here. Alright, what's the machine doing now? Let's play What Did I Accidentally Tell the Machine to Do? It's a fun game. I play it all the time. Right now it looks like we're cleaning up the edges that we already cleaned up before with the bit that was too large. Or rather, where the machine thought the bit was smaller than it was. You should plug the newest item to the merch store other than the limited edition shirt. What is the newest item to the merch store? What a great question, Jared. I believe... Well, okay, the shirt is great. Measure your tool length shirt, awesome. We also have BPS.space masks. They are not N95. They will not protect you from, you know, everything, but they're masks. They help prevent the spread of disease, or mitigate it, rather. I should not be... You know what it is. It's a cloth mask. I am the worst salesman that there ever was, but I'm also very focused on this machine right now. But if you want some, you can go to bps.space/shop. There's also a shirt that says measure your tool length. A shirt that was funny at first and now is all too real to me. What are you doing, machine? Why are you like this? Why do you do this to me? Well, we're taking a big cut now. I'll tell you what, the cut doesn't sound bad. It sounds alright. Astro Guy, do not buy that dog. Don't buy the dog. Do not buy the dog. I mean, it doesn't sound good, it just doesn't sound bad. I can already spot the problems with the cut. The dog is on sale. You just shouldn't buy it. Like, what am I, a monster? I'm gonna charge you $8,000 for a dog? No, it's like 50% off. Of course it's on sale, but don't buy it. All right, hold on. Cheers. This is number 4. I should probably cap it at this. Not that there's any problem with drinking 4 non-alcoholic seltzers, but you know what I mean. Too much water is a bad thing. You can see the errors, man. There's a big step right there. Oh, it's doing the chamfer. Alright, we should probably do some... Oh, Charlie, pop quiz. Why isn't the machine cutting both ways? Excuse me. And why is that extra important on a Nomad versus a Haas? Oh my gosh, I can't even remember the term for that. Plunging. Oh, climb milling. Okay, I'm not taking anyone's answer. I think Andrew got it. It's climb milling versus some other type of milling. I cannot properly answer this. I should put earmuffs on though. Oh my god! They were on my head! I went looking. for them. Oh, climb versus conventional. That's what it is. Joe, why you didn't land yet? The videos in which I do my landing tests, I think, a pretty detailed job of explaining, what the challenges are and what's not wrong, or what's not working, sorry. But, I guess if I had to pinpoint 2 reasons for not landing, it would be leg bounce and GPS antenna placement. Both of these are easily fixable problems, so hopefully soon, we'll see. Yes, Parker, there is nothing wrong with consuming 4 non-alcoholic seltzers. That's correct. Am I still trying to land? Yes, I am. Do you use differential GPS? No, I do not. It would be great and probably helpful, but you can do it at this time scale and altitude speed scale that you don't need differential GPS. The math works out that your sensor noise is not a problem on this scale. And so if you're having problems, it's because you're not processing your sensors well enough, not because you are lacking the necessary sensors or sensor resolution. Okay. I'm trying to... Okay, Dino says, I'm trying to do active control, and I want to use MathWorks, but IDK, what add-on products to use? Which products did you get? So, okay. Oh, cool. Hey, good luck, Andrew. So, I have the Aerospace Toolbox, or Aerospace block set. I've got the Optimization Toolbox, and a few others. You can use MATLAB if you want. You can also try writing your own simulation. That's a popular route that a lot of people take. If you are familiar with Python, the equations of motions, are not too complex to write out and do a simulation like that. So that's one option. I think some people have had luck in, I know T0, Rob from T0 has had luck in simulating with Excel. I don't know if that's the easiest approach or the most straightforward, but you can do it that way. All right. What 3D modeling software should I start with, and what do you use? So I use Fusion 360. I really like it, and I actually think it's the right place to start. Right now, it's free for hobbyists. They keep changing it, and I think eventually it won't be free for hobbyists. This is kind of the way that a lot of this free software goes. But I use Fusion 360. It's pretty full-featured. Yeah, I guess that would be my recommendation. All right. Creo or get out. Get out of here, Jared. All right, let's clean this up. It's definitely trying to chamfer it. It's not doing a great job because, again, it's predictably not doing a great job. It's a flat end mill, but it's trying its best. Let's do some more questions. If people have more questions, put them in the chat, and I will do my best to answer them. Dude, look, we are removing, no material. Oh. As I say that, cat or run through a minefield? I think free cat is probably a lot better than it was, but it was really, really, really bad when I tried it in like 2015. However, I also didn't know what I was doing, so that could have been part of it. What is the buckling load of this panel? Great question, Charlie. I do not know the answer to that. Alright, oh, I wanted to get a macro shot. The trick with changing lenses in front of a machine that is spewing out chips is to do it really fast. Okay. Hear me out on this shot. I know it's low frame rate. What we're doing is we're shooting a time lapse, and the deal with shooting a time lapse. See how it says VFR 5? This is a little bit of film stuff for you. This the power stance. So this is okay. Well, it was on purpose until that. The deal with this is that when you shoot with a really blurry shutter like this, it's Jared says it right. It's visual frame rate. So if you put it at 5 FPS, when you speed it up, it will have the motion blur as if it is happening in real time, even though it's sped up. So you're not just taking the frames, you're taking the frame, like the shutter speed, and expanding it to what it's supposed. So VFR is variable frame rate. But you don't just want to vary the frame rate, you want to vary the shutter speed as well. And varying the shutter speed allows the time lapse to look a lot more smooth and less choppy than it otherwise would. Now, I picked a pretty bad time lapse to do on this one, so I'm going to stop it and try something else. I know that this looks bad. I promise it will be worth it. I mean, I guess I can't promise that, but like, I don't know. It should be worth it. Hey, and we're more than halfway through. Is my butt in the shot? Did I get a little crack view? Oh, are we talking about this old Tony? This old Tony is great. Model Space, what are you ripping off? I'm curious what design you're ripping off. Some of the designs I make are worth ripping off, and some of them are not. Alright. Went Maho. We'll be out of the low frame rate soon, I promise. Oh, the launch pad. That's fine. The launch pad design is good. Oh, we're doing chamfers again. What is 1/5 of 4 minutes? $50 seconds? 45 seconds? What is 1/5 of 4 minutes? Well, 1/5 of 5 minutes is 1 minute. All right, we're done. Almost there. This is the best comment. It's not the milling that's interesting. It's the person trying to operate the mill that's amusing. That's perfect. And it's true. The milling is uninteresting. It's me messing it up every time that's interesting. Everyone say bye to Jared. Say bye, Jared. Bye, Jared. Thank you for joining. Oh, y'all want to see what I did? It's not as bad as you might think. Oh! We're through! We did We made it through! We made it through! Oh my gosh! Yay! Yes, queen! Slay! Woo! Is it good? No. But is it almost done? Yes. Oh, this is awesome. I love it. I don't think we really need this pass, but I'm gonna let it run. Someone buy Jared a Zcam, and he'll get them Subway. That's a good deal. Get those Italian herbs and spices. That bread is on another level. My shoe's untied! Can't have that. Woo! Yes! Oh. That was like an hour and a half. This would have been a 30-minute 3D print. 30-minute 3D print. Okay. Oh, wait, we're not even done. Okay, we're not even done. Because we need to drill the holes. We didn't drill a single hole, so we need to go back to the 16th inch bit, and we need to do a bore operation. Oh, God. We're almost there. We're like so close, right? We're so close. Cancel. We're so close. We're almost there. Stick to the end, folks. We got 129 people. Let's keep it over 100. We're almost there. We have to get through the bore operation. That's the easiest one. That thing is straightforward as all get out. But, yeah, we have one more thing to do, and then the sleds are ready. And then I can assemble the avionics bay. That's the last part of it. Okay, great. So that's done. There's plastic everywhere. Literally everywhere. That's going to be fun to clean up. And I think it's a great job for future Joe. Current Joe is not thrilled at the idea of cleaning that up. But the Joe of tomorrow, oh man, he's stoked about it. He loves it. Oh, that's not even pointed at the thing. There you go. Oh, gosh. All right. Well, the vacuum is out of battery, which is a fun thing. And there's snow everywhere, pretty much. Look, we can just use the same things and then do a new bore. Here we go. This is the last operation. All right, the tool is a 1/16 inch flat end mill. The holes are as follows. 1, 2. Look, it even generates them like right away. That's just exquisite. So this is the thing that holds Ava. Slightly concerned about how flimsy it will be. Ah, why? Fine. Clear. Oh, because there's a... I get it. Yes, I understand. Clearance height reference can be that. Plus 10 millimeters. And we're just doing some bores, man. Just boring it up. Love a good bore, huh? I'm so done with this whole process. You know when you say like this could have been an email? This could have been a 3D print. That's what this could have been. All right. Adaptive 4, even though it's a bore, I do not even care. 0% of me cares that this is not named correctly. All right. Let's vacuum this up, and then I just need to film it. Okay. Very nice. Love it. I will say, I'll tell you what, the double-sided tape, absolutely 100% pog, if that's how you want to say it. Like, great idea, me. Good job, me. I did it. Oh, man. The cuts are really nice, too. Like, I kind of get it, man. This thing looks great. All right, so we're going to do the bore. I'm going to put on this lens. We'll leave it open. Okay. Start. Here we go, folks. We're almost there. This is it. This is the home stretch. This is the last operation. After this, we're done. Hundo P, as the kids say. It stands for 100%. Hundo P. Hundo P, folks. That's what we're going for. Not 70p, not 80p. Hundo. All right. Do it to me, Daddy-O. Here we go. Whoa! Oh. We did it! Yes! And at no point did I complain. Should we take them off? Should we try to get them off here? I'm a little concerned about that. Let's see how that works out for us. I also need to replace the camera battery, so stand by. It's going to go dark for just a second. I'll be right back. Oh, gosh. Alright, yeah, let's take these things off and see how they look. Oh, whoa! That was 1,000% easier than I thought it would be. Sorry, I should have waited till the camera was on. Oh my gosh. It was like nothing. Alright, here we go. Look, you can see. Hold on. Get a little higher up. You can see two things here. You can see the demo thing that I printed for when I got my machine, and then you can see the cuts that we made as part of milling out these pieces. Take this one off first. Oh, that's really flexible. I don't like that. This may be a lost cause if it's this flexible. Okay, so this is worse than a 3D print. I guarantee it. Like, well, okay. What I'd rather do is put spars along here and then iteratively print it until it's just barely touching the computer. This is not enough. The reason that I chamfered it like on this profile was because it was interfering with the airframe. Like it was an interference thing with the airframe. Like the GPS antenna was clonking right into it. So that's not good. This one is probably fine. Almost certain. Get it right under there. Woo! There we go. This is going to take some work to get that off, but hey man, this happened. Like, I did this at least. Not super flexy, which feels great. This is certainly stronger than a 3D printed part, and it's probably going to fare better if it hits the ground. Well, I'll tell you what, folks. This was a learning experience. Every time I have milled something, it has been a learning experience. And I never really come away feeling like great about it. But I did it. Okay. I'm trying to think of if I have anything else to say here. I mean, this looks great. Okay, Charlie, so yes, I've been traumatized by the mill. I would like to emphasize, like, this mill is for a specific set of things. And actually, polycarbonate is one of those sets of things. But I have previous trauma from trying to mill aluminum on this thing, and for whatever reason, there's some resonance on this machine that just makes it sound like it is screaming the whole way through. So, you know, we will see. what material the Ava sled gets made out of. This is great. This is holding the telemetrum. It's going to be awesome. I feel like I might just have to do it out of ABS, or I don't know. We'll find something else that's at least printable. I can't go through the milling process again. We'll see. We'll see. It won't be PLA, that's for sure. I also want to say, because of the date that we're launching, I don't have to worry a whole lot about heating. If we were launching in the middle of the summer, I'd have to really worry about PLA parts or even some ABS parts like slightly warping in the sun. Not a big deal. We're launching... I don't want to say when we're launching, but we're launching soon enough that it's not going to be a big deal about heat. All right. This has been great. Thank you all for joining me. That was a 4-hour stream, which is kind of insane, but yeah, I don't know. There will be a video on the BPS channel about this new rocket pretty soon, and I've just lost the ability to communicate effectively with the camera. So thank you everyone for joining, and I'll see you next time when I carbonate a hat. Okay. Oh, sweet. Ricky, White Knight tail section starting on the printer now. Awesome. All right. Well, this has been lovely. Oh my God, I'm still rolling. Whoops. This has been lovely. I'll talk to you all soon. May your skies be blue and your winds be blue. May your skies be low, and also having with your wind to be low. Amen.